First step is the shredding process that is done by knives. In this process, the hard shells of the cane are removed. The cane then passed through another types of knives, where they are cut to smaller sizes. This is the chopping process. After that comes the crushing of the cane, which is considered as first step towards removing the syrup from the cane. All the previous processes are applied to ease the syrup extraction process by increasing the active surface of the cane raw material rail. The milling process is then applied where further crushing takes place on the crushed mills. The addition of water in this part is very important, as it increases the size of syrup obtained and reduces viscosity. This is important to ease the obtained syrup further processes. After being filtered, the syrup then is stored in weighing tanks before added to the liming tank. The weighing process is very important to calculate the amount of lime needed for clarification. Lime is then added to assist in the sedimentation of colloidal particles. The syrup is then heated, then transferred to clarifiers, or continuous settlers where phosphoric acid is added. The solid parts, scums, collected from the bottom of the continuous settlers, is then transferred to a rotary vacuum filters to remove the adhering syrup. The syrup from the clarifiers is then transferred to a multi-effect evaporators, where the syrup is concentrated by evaporating most of the previously added amount of water. The evaporators operate under vacuum to reduce the cost of evaporation and to utilize the temperature of the syrup along this process. The syrup loses over 40% of its volume after this process. The syrup then enters storage tanks before being pumped into a vacuum pans. The objective behind this process is to increase the concentration of the syrup and to generate a supersaturation concentration, which enables the syrup to crystallize. The water concentration from this process is reduced to only 10%. Previously formed sugar crystals are also added to the syrup at this stage. The crystals act as a nuclei for the crystallization process, as they also trigger the formation of crystals in the crystallizers. The mixture of generated crystals and syrup is separated using centrifugal units. The sugar obtained after this process is raw sugar, which is brown in color. Sugar after this process should undergo a refining process. This is usually made by adding bone char or activated carbon to change the color of the sugar. The mixture of syrup and formerly generated crystals, which is then called mesquits, is then added to the crystallizers. As the crystallization process continues, the concentration of the syrup is reduced and the process is terminated when concentration reaches the saturation level. After that, the syrup is then recirculated back again to the vacuum pans for removing more water and thus obtaining a new supersaturated syrup. The process continues till the amount of sugar within the syrup are not viable to be separated. The resulted syrup, molasses, is then discharged and considered as waste.